release. No.
Control, back deck, Hercules away.
So as soon as we release, I give a little spurt forward. And a lot of pilots will turn here and burn.
Control deck, that's Hercules past the transom.
The reason we have that past the transom call is then I turn, and not before.
Control deck, that is tether all out.
Confirm tether all out.
Where I did mess up yesterday, I got the tether tight before I got the behind the A-frame, and that caused Atalanta to be pulled over to the port side there, which is not pretty. So this time I turned into my tether a little, which I don't like to do either because I've got wrapped around the tether before doing that. So that's why I prefer the little more speed of the vessel, but Mike likes it nice and slow, so it is what it is. Now I'm full ahead on the thrusters there, pinned as it were. I like it when Atalanta's bucking in the braces. Come on, Dad, let's go, let's go. Looks like we have a little surface current the other way this morning, Chris, so to the south.
Yeah, that is correct. I think they were trying to balance the wind in the, but there's not actually a whole lot of wind, so I don't know.
Yep. Not the thrusters yet, though.
Control back deck, Atalanta is away.
Hercules is dive, dive, dive.
Hercules is dive, dive, dive. You happy now?
Yes.
No.
Come on.
After you
Dive, dive, dive.
Yeah.
after you 068 reps and
Roger.
start your mezzos.
Roger. I'm on it.
See, now he listens to me.
That's actually Jaden on it. Assuming they have turned on the sonars, let's find out. Did you turn on both your sonars? Beep, beep, beep. What will also happen here, Jaden, is Herc pilot will get a little rambunctious and go down too fast. Get double digits there. And the winch we asked for 10 to 15 meters a minute. So they're going a little fast there, actually. 16, breaking the speed limit by. I must not have my seeking turned on. Science. Yes, please.
This is an audio slate for dive 2078. UTC time is 19:14:45 mark.
Cutting that mark pretty close today.
Sure did.
Ooh, I'm getting way down there. I'm going to fly forward for a minute. I'll double tap auto dip, auto heading. No. Momentarily. Rachel has advised me to turn on Herc's Ethernet bottle first, so I do that at DOC. But it's on another page, so I haven't poked over yet.
Control, back deck,
Ready
all
for
stop
control.
by 0 meters. Control's been sent over to the van.
You ready?
Yep.
We're ready for control.
Okay, Jaden, running down 25 meters a minute. It's a wonky heading there. What's going on there?
You ready to hold position?
Sure.
Bridge nav, hold position.
Well, we weren't too late this morning. Okay. 50 meters, all good. Green board, except for a hot motor. 78. That's crazy. You should have upper and lower in approximately 45 seconds. And you should have Norbit.
Bridge nav. If you're hunting for a good heading, the current is coming from about 310, according to the ADCP.
Okay, Jaden, I'm making, as you can see, yeah, you can keep up with me now. All good. I just watch the cable going across the deck there. When we're this shallow, we don't have a lot of weight on it. I like to have another 1,000 pounds on there before we hit the speed. But depending on the weather, no one size fits all. But you can get in trouble with that lighter weight going too fast, so Atlanta won't fall down. And so as we heave, the Atlanta comes up, then the ship heaves down, then the cable comes slack, and you'll get slack cable there, which will make it go slack everywhere. So the really bad place for it to go slack is on the traction winch. So like a bait caster, when you don't have your magnet or your thumb set just right, that's the winch being the bait caster. So if we had any significant weather, I would not be going this fast, this shallow. I'd run her down to about 250. The other thing I'm lagging on too is, we'll see if I should have craft comms here. Why do I have all the fidgets? Want to fidget, Chris? Want to Fidget? Huh? Give Amber a fidget.
Dan, are we clear to power on Thermocam?
Roger, yeah.
Thank you.
It does have, it should have done its thing by now, so you can just go for it. Look at those snappers, freshly sharpened blades. Freeze fail.
All right, good morning. Let's go ahead and this is our 4 to 8 watch and go around and introduce one. So you can say your name and your duty for today. We'll start with the front row.
Good morning, everyone. I'm Dan in the Herc chair. My duties are general roustabout and all-around troublemaker.
Hey, I'm Chris Krasnowski. I'm here as navigator today.
Hi everyone, I'm Jaden. I'm here as the ROV Atalanta co-pilot.
Hi, I'm Amber. I am here as the video engineer.
Ali, everyone. I'm Brian Kennedy. I'm the Chief Scientist at the Ocean Discovery League and the External Science Advisor for NOAA's Office of Ocean Exploration's Pacific Islands campaign, and I'm the watch lead.
Ali, I'm Harold. I'm a PhD student at the University of Hawaii at Manoa, studying deep sea ecology in the oceanography department.
Here, I'll get you a
And
set.
I'm in the science chair for 4 to 8.
Good morning, everyone. My name is Kinlan Yao. I will be the data logger for this watch from 48. Off watch, I am an undergraduate student at Palau Community College, majoring in STEM disciplines.
And my name is Kim Etsity, and I'll be in the SciComm seat. And I am out from Arizona, New Mexico region. Good morning.
Still got the rocks in the flush jar. Okay. Tilt that lantern camera down into the light a little, which I'm doing. If you see it moving, you're wondering why. Just say it. Maybe up just a bit so we can see both comps there still while we run her down. Layout. Slot 2, head 1. Picture in picture. Which one don't I want? I don't need to look at a bunch of winch gauges. What PC do we got Thurber on tonight? Then everyone will know where to find it. I think it defaults to the Hercules. I see it, thank you. Do you have both the NDI streams over there? I haven't looked at them. Do you not see them? Yeah, I haven't turned them on yet. I thought I turned them on. You want to hit blue for me, Chris? Want me to DJ today?
All right, should be on.
Do you usually forget it first? Yeah, so you'll have to double tap it again. Yeah, me neither. Sorry. Can you tap it again? Oh, I know. I gotta go. Yeah, let's. Yeah. It's gonna time out. You'll have to tap it. I looked around for, tried to find an alternate headphone so I could like plug a little gizmo in there and have it Bluetooth to my Bose headphones. Couldn't come up with anything. Oh, you can yeah. It would have been slick. Plug in any headphone you want. Yeah. I think they do that on Poipus. Amber's got a pair of David Clarks over there.
Yeah, it's funny how the people who control the budget for this room suddenly have the fancy headsets and all of us don't.
Shots fired. Pew, pew. Yes, it is funny. Funny, not, it's not. Ha ha. You should, I've complained about it since day one and tried to get the people that control the budget for this room to actually wear the headphones that you are all wearing for more than 5 minutes. They're actually not cheap headphones, are they, Amber?
But they're not David Clark's. Yeah.
But the ones United Airlines give me for free sound better than those. They're just proprietary, which doesn't necessarily make them.
Why are they? Well, I mean, this is just a 5-pin XLR, right? Port.
What's that?
The plug's just a 5-pin XLR, so it's a standard port.
Yeah, there's. You'll have to do it again, Chris. I'm not having any luck. It's really making me mad. There is a list of published headphones that one can purchase out of one's own pocket, and they range from, I think they start around the $300 mark, $500 for some decent ones. They go up. And I spent some time researching all of them, and you know, you get on the professional video engineer forums, and it's like, oh yeah, you got to rock up to your control band with these ones. So it's a personal thing that it's like one of the tools of the trade that you have. Like a, you know, musician has a guitar. Have any genre preferences? What's that?
All right, good morning to all our viewers. Today we have our Dive 2 of Lee Boys Voyage 2. We are descending our vehicles. Our max step today would be 2,084 meters. Would this be a good time to go over the dive objectives?
Sure. So we are diving on a seamount relatively similar to yesterday's. It's a little bit deeper. So we're going to bottom target's about 2,100 meters, and we're probably getting up to about 1,200. We actually had a lot of debate about how to approach this seamount. It has two what looks like pretty good slump scars. So these are landslides or mass wasting events, one to the northwest and one to the northeast. One is a little bit, the one to the northwest is a deeper kind of channel, and the one to the northeast is a broader kind of whole slope failure on like the entire side of the seamount. And then there was kind of a ridge feature on the southeast side. And all three seemed like really good and interesting targets. And of the three of us who were working on the dive plan at 2:45 this morning, each of us advocated a different side. So we kind of basically flipped a coin and decided to try the larger, broader slump feature that has more remnant, like rubble from the slope failure, as kind of the compromise. So the goal is to land on the very summit of what I suspect is a giant sediment pile or a rock pile that has fallen off the seamount. Should be relatively flat. We'll transition over that area and then make contact with the relatively steep side of the seamount that is the scar from the slope failure, and run straight up the side of the feature to the summit. This is going to be a little bit longer of a dive track than we had yesterday in about the same amount of time. Actually, a little bit less time because we got more time in the water column. So we shall see. We're going to have to make good time on the seafloor again in order to make the summit.
Brian's talking to himself right now.
No, I'm not.
We
Make
have
good
viewers.
time on the seabed. Make good time on the seabed.
Oh, yes, that I am talking to myself.
Oh, yeah.
I was like, I'm appropriately on SPL.
Note to self, make
Note to
good
self.
time on seabed.
Four
Note
to
to
8.
Dan, too, because I'm easily distracted.
4 to 8 in the afternoon, Brian would appreciate 4 to 8 in the morning, Brian, to make some tracks.
So here's a personal question, Brian. Do you prefer the 4 to 8 watch?
Yeah,
You do?
I do.
Why
It's
is that?
my favorite. So I really love getting off watch, having breakfast, and taking a nap.
Me too.
It's really nice. And then when we're not diving, you're kind of up for sunrise and sunset. It's a trade-off because you miss sunrise and sunset if you're in the control van every day, but the days we're not diving or we're on deck, I'm always up to see sunrise and sunset. But yeah, 4 to 8 is my preferred watch.
Yeah, it seems like you get to see the beginning and then you get to see the end, right?
It has been that way this case. We are not that predictable as a general rule. As soon as we have a longer transit or something like that, we'll fall into a different pattern of who's launching and recovering. So that's not a foregone conclusion. Last leg, we were almost not working in the morning at all in terms of being in the bottom. We were on the cycle where we were transiting normally from like midnight to noon. So that just will change depending on how long our transit between dives are. But today, yesterday, and tomorrow, our dive sites are very close together, so we can do like a minimum turnaround of 8 hours. But there will certainly be times later this leg that we will have much longer transit times or need to do more mapping, and we'll end up with 12 or 16 hours in between dives.
Oh, that's cool. What about you, Harold?
Well, this is the only watch I've ever known, so
Do you like it so far?
I do like it. I think I agree with Brian's rationale. It's not too terribly different from like a semi-normal sleep schedule, so it's just getting up a bit earlier.
You just get to watch the sunset on the monitor.
Yeah. Or the sunrise on the monitor.
Oh, yeah.
Out of the corner of the winch cam. But yeah, it's good.
Yeah, watch schedule is one of those deeply personal things that elicits strong feelings of different people. I was talking to a colleague on shore just before I came out, and I was like, oh, I hope I get the 4 to 8 watch. And she's like, what? The 4 to 8 watch is the worst.
So who gets to make those schedules?
Dan?
Daniel. So do you get first dibs and ask him, or?
No, I'm not even. I think it might have just been total luck. I'm not even sure he knows I like this watch.
Oh, yeah.
I missed my trackball here. I used to have a trackball. Talking about personal preferences, I took it out just for Robert Waters, who does not like trackballs.
So we've got about 45 minutes till bottom, and then we'll need 10 minutes or so to get set up. So we're just shy of an hour away from science. Have a good sleep.
See you later. So Quinlan, how are you enjoying the Nautilus lately? So far?
So far, I'm having a lot of fun. I really enjoy my watch dives. I thought I would struggle because it's 4 to 8, and I usually wake up at 6 every day. But I'm managing now, and I actually prefer 4 to 8 because I like being one of the first ones to see the first dives and actually seeing the bottom for the very first time. And also like being the ones to see the ROV finally coming back up. So it's nice. I really enjoy it.
Thanks for sharing that. How long does it take to you guys to get the dive plan situated? A couple hours or?
Nah, generally the actual picking of the dive is usually about 15 minutes.
Oh, okay.
But there's, hours of mapping and then 20 or 30 minutes of mapping data processing to get all the maps ready for us to get around and argue about which spot we want to go. So it's a little more involved than the 15-minute. We've got Renato Kane, who's our mapping coordinator for the expedition, who gets up at all hours of the day to work through making the maps and everything in order for us to have the pretty maps with the backscatter and everything to look at and figure out where we want to explore. And then the generation of the dive plan itself is pretty formulaic.
Oh, yeah. So good morning to our viewers. We are descending our vehicles. No previous dives have been conducted on this unnamed seamount, which was mapped for the first time this morning by EV Nautilus. So thank you. Good morning. Our vehicles are reaching 924 meters, sending down. So how much time did you say we have until we get to the bottom?
36 minutes transit
Ballpark.
time, then plus another 10 minutes of white balancing and whatnot. So about 45 minutes from the start of exploration.
Okay.
Have any volunteers from the back row to come sit up here and relieve me for a minute? Eeny, meeny, miny, mo.
Harold, go for it.
Come on, Harold. Get up
All right,
here.
Harold.
Does that mean I get to drive?
Yeah, you do.
Air Corps
Hooray.
drive, but yeah.
Bring your headset, maybe. Can you hear me, Harold? So you have to unmute there to... That's this guy. Push it up. And nope. Push that one up. So when that one's green, it's on SPL. So you're listening, and then that one is up is unmute.
Okay.
Yeah. So to mute again before you unplug your headphones, you get the red light there.
Got it.
Got it?
All right.
How's it feel?
I feel powerful.
Powerful.
Oh.
Yeah, this some smart aleck me put this
man.
on here.
So many
It
knickknacks.
says actually.
Is that just what it looks
ego
like?
Inflator. I really, personally, I strongly dislike this chair, and I argued
It's a bit better than our chairs.
to get it in there. Actually, it's not. Those are like $1,000 lifetime guarantee chairs. This is some,
Really?
yeah,
Wow.
wonky captain's chair, and it's bolted to the floor, which is really annoying. The biggest challenge sitting right there is complacency. It's 99% boredom
Hmm.
and 1%. Oh my God, we're not dying. Pure terror. But you want to walk through? Any
Sure, yeah.
Questions off the top of your head, or?
Here, let me turn you up.
Yeah, sorry. You can turn
You're
the
good.
main volume up.
Yeah.
These headphones are, I'm old and deaf, so I really struggle with those to hear, especially with
Yep.
the ambient noise in here.
You're
And
good.
Some of the scientists in the back row are really quietly spoken. I don't know. Where do you want to start?
I don't know. What's the most important screen or number I should look at if I want to not break it?
So right now, the thing that makes me the most nervous is what is in front of Jaden. So there's several hundred horsepower of winch turning there,
And that's this thing? Or,
yeah. So
yeah.
Jaden's controlling it with the lever there at their right side, and watching the 6 cameras we have down there. There's only 5 of them displayed right now. There's
So you're just holding this lever up, and that's controlling the
yeah,
accelerator?
we're bending the rules slightly, but it's because what Jaden's trying to do is keep the delta, as we call it,
Right.
so, the same. So if you look, what we're watching up here in general is, one, we're watching the winch to make sure the cable's coming off correctly.
Right.
The level wind doesn't run away, and you know, everything looks status quo there. But what we're also watching is these 2 little screens up here.
Yep.
The one that's blinding you with our...
So that's the 2 ROVs, like going like that.
Correct, yeah. And that number is associated here with our what we call our delta. You hear us refer to the delta all the time. So when we go down through the water column, we like Hercules just a little bit positive, which makes that number positive. And this number here is our speed. So that's the speed of the winch in meters per minute. So we're going down at 31 meters per minute. Hercules is now 1 to 2 meters below Atalanta, which you can verify there with those two pictures. So the one on the right is all Hercules, the one on the left is Atalanta. So those are the two tail cameras right there on the split screen.
Sure.
And we can verify that in 3 or 4 places. So visually there, I can tell by my heading, Hercules and Atalanta heading are opposing there, and I can tell here that they're opposing. So the red one, the red arrow with the dot is Hercules heading, and the dot indicates if I was to have auto heading on, what that would be, and then the little white one is Atalanta's heading. The other place.
So they're opposite.
Yeah, they're opposing. So we're looking away from each other, or what you'll hear us say is tail to tail. The other one that I watch constantly is this one. So the pink one is Atalanta's position, and the yellow one is Hercules' position.
Right.
And the little arrows that unfortunately are not vector arrows, they're just, static arrows, are facing away from each other. And then the other one I watch too is also the vessel position. So in case Nautilus takes a holiday, or we have any issues with the DP, or the bridge is changing heading and I'm not aware of it. So if they change heading, that will obviously affect Atalanta, which could affect Hercules.
Right.
And those, the numbers here are, the purple ones are all the vessel. So ship's heading, speed, and then course over ground, speed over ground and course over ground. Then Hercules heading, Hercules depth, Hercules altitude, and Atalanta heading depth and altitude. And some of the other numbers up here that are changing. So this is the tension on the umbilical on the 6/8. So that's the weight.
Right.
That is, there's a load cell in the overboarding sheave in the A-frame, which is in that little bitty picture up there. So the cable coming up the back of the winch over the up out of the deck right there by the ROV hangar, going across the deck to the A-frame, and that big overboarding sheave, there's a load cell in there, and that's giving us that number. And the graphs are just, we use the graphs when we're kind of watching to get a reference, get a feel for if we're going uphill or downhill for the last 5 minutes or so. And the other one that is verifying the position, so on the sonar screen, on the upper screen up here, the one on the left is Atalanta sonar, which is a downward facing 360-degree sonar.
Right.
So the red dot that you see, and those are 20-meter division rings, so we typically have Atalanta looking out 100 meters. So I can tell at a glance there that Hercules is just over 30 meters behind Atalanta. So on those sonars, up is always the heading of the particular vehicle. So in the case of the one on the right-hand side, that's Hercules sonar, those, it is upward-facing 360-degree sonar, and we typically have those range rings set to 10 meters division. Hercules looks out about 50 meters with its sweeping sonar. And then this one here is a smaller sonar that's downward facing, and it's in Hercules front bumper bar, and it's just doing 180 sweep back and forth. And we play around with the range on this one a bit, but it's still where I had it set last night at 10 meters. So when we're on those vertical walls, I can judge at a glance how far I am away from the wall.
Right.
And I use that quite a bit. So this 2.5 meter range ring, if there's a vertical wall and large animals, I try and keep my 2.5 meters away or so, something like that.
Right.
I know generally I'm safe if I'm at least 2.5 meters away.
Is there a reason that Atalanta isn't directly under the ship right now? Is that?
Yeah, so when we launch ROV Atalanta and Hercules, you can see the ship's history here.
Right.
So when we launch, the ship was, I got to do this every time, northeast, southwest. So the ship was facing west.
So is that just the lag in the cable moving?
Right now it's the pendulum effect. So when we launch, we get the ship moving typically around half a knot, steady as she goes. And that way when we put the ROV in the water, if the lights go out or anything happens, it's always behind the vessel. So kind of, it's
right.
it's literally getting towed by the vessel.
Okay.
And so these are 10-meter division boxes, just to give you some scale. So when we were still on our first cup of coffee, we got the boat moving, and it moved along this line while we were launching until we got down to 50 meters and made sure everything was okay. And also once the vehicles are below 50 meters, if the lights did go out, you always got to plan for the worst. Hercules could not float up into Nautilus.
That makes sense.
And then once we were all happy with there, Chris actually held position with the vessel until we got down a couple hundred meters, and then he's asked the vessel to move back to the waypoint for our dive site. So why Atalanta, to answer your first question, why Atalanta is behind, it's a pendulum effect, or what we call our layback. So as the vessel is moved,
right,
it's swung out 10, 20, 30, 40, 50, 60 meters. So it will eventually swing back. The other reason it's being pulled out is, if you're ready, I'll switch to Herc's GUI. So right now I have I look at this box quite a bit. So the little red lines are the vector of the thrusters, or how much thrust. Some people call it effort. Right now it's an RPM. I usually have it in percentage. So right now I'm giving 100% down thrust, obviously, to maintain that 30 meters a minute. But the other thing I have is about 20% forward thrust on Hercules, and you can see the horizontal thrusters spinning there. And that keeps the tether tight, but I probably have actually too much forward thrust, so it's actually pulling Atalanta. So the vessel's moving east, and I'm pulling it west, so that that kind of exacerbates the layback a little bit. That makes sense. I could probably relax that. We'll do that here in a second. So the numbers, the only numbers I look at constantly here, besides the dashboard lights, and it's funny, I'll notice those not red sometimes, but I look at the compass quite a bit, and I look at the percentage of the thrusters. These numbers are, I'm half blind now in my old age, are hard for me to see, and they're not in the typical order, heading, depth, altitude. So I more rely on these, and the rest of this is just to turn stuff on and off on the vehicle. But the other ones I'll look at too are these radio buttons here, and they also correspond to the these first three buttons here, and those are the three main auto functions on Hercules. So we have auto heading, auto depth, or altitude, depending on which one is selected last, and then auto XY, which is kind of like DP for ROV station keep.
Cool.
And then the last one we use all the time is the stick lock. So it's like the old school cruise control on automobile. So you set your car to 55, and it maintains that. It's just holding. In the case of it's actually the one in the old cars are smarter. They maintain a certain speed. This one is just simply locking the joystick commands in.
So we're locked right now on our downward.
Yeah, so
Set.
basically what I've done is I've given it full vertical down a little bit
Yep.
front, and then I've pressed that button, or the button on top of the joystick does the same, and that's locked it in. So some of the other controls here, the ones, this one is not functional at the moment. We're in the middle of software upgrades. It used to control the Hercules main camera, but the one on the far left, that is your vertical control, and we like to think we're flying airplanes, so we pull back on the verticals to ascend and we push forward on them to go down. That's not always the case. A lot of ROVs or cameras, down is down and up is up. If you ask, I think we do it wrong as well, but if you ask, all 6 or 3, if you ask 3 ROV operators, you'll get probably 6 answers on which way that should be. Like me, I can do either one. I can drive a right-hand drive car or a left-hand drive car. I might struggle with one until I get used to it, but at the end of the day, I can get in the car and drive it. So in the case of Hercules, if you panic, you pull back on that stick and you'll come up off the seabed, which will cause you to lose visibility because the thrusters will then thrust down and disturb the seabed.
Cloud.
Yeah, dust cloud. So I typically, while I'm operating, I'll just let go of it, and we have about 50 pounds positive buoyancy, so Hercules should simply just float up slowly away from the seabed. And that's in general true of any of the controls. I find I get out of trouble much easier if I simply let go of the sticks.
Yeah.
It's, 6,000 pounds of positively buoyant ROV, it's not going to go anywhere unless there's excessive current or something. But even then, it's, going to slowly move, like, this kind of speed.
Cool.
It's not going to go any faster than me walking from here to the back of the control van. So the other main stick here is, of course, the joystick. So forward is forward, backward is backwards. Right or left causes you hear us during the deck check, so that's our lateral thrusters. For some reason, we say lateral right, lateral left, as opposed to turn to starboard or turn to port. So when you twist that stick, you're actually reversing one of the horizontal thrusters. When you move it to the side, you're engaging the lateral thrusters. And the lateral thrusters on Hercules are not very powerful compared to like a typical ROV has 4 thrusters, 1 on each corner. So when you lateral, all 4 thrusters are moving. They're, vectored about 45 degrees. Hercules has the back 2 horizontals are almost like boat propellers. They're almost straight back. So it behaves more like a skid steer.
Right.
So when you turn it, one's going forward, one's going backwards. And the laterals are smaller, and the water's going through the vehicle, so they're not as effective. So, any questions there so far?
So stick to the left shifts the whole thing, but if you
Correct.
twist it, you actually change your heading.
Right, like a skid steer.
Cool. Nice.
And,
So when you're flying, are you actively, so usually you have the auto depth locked on while you're just flying across the bottom?
typically, no.
Typically, no?
I don't have any of the autos on. The only time I have the autos on is like when I'm lazy. Like if I have the freeway to myself, I'll hit cruise control. But for the most part, we're in traffic all the time. We're in city traffic.
Right.
So I like to have control of the vehicle. What we do, there's one more thing I didn't talk about. We have this Z bias here.
Right.
And we set that typically, if we're ballasted correctly, around 30% down thrust. So that will keep all the time thrusting down, and it will keep Hercules from floating up away from the seabed.
Right.
That allows us, if we have that dialed in, that allows us to get those on the fly zooms without bouncing
Yeah.
up and down. The autos will actually oscillate significantly. And
So when you're flying, is the idea that you feel neutral, or are you constantly pushing down just a little bit to be safe?
it's personal preference, and it depends on what we're doing. It's nice to feel neutral, but my personal preference is to always be pushing down. That way when I let go of it, I come away from the seabed. If you're trying to be neutral all the time, you're going to wind up in the seabed, and your nature is to pull back, and then that disturbs the visibility and we can't see anything. So my personal preference is to fly a little bit light. And so with an ROV, remember this thing weighs 6,000 pounds, as much as, you know, a large car. And
Right.
it has 20 horsepower, which is about half of a Volkswagen Bug that was made in the 1960s. 20 horsepower is, you know, my lawnmower has 20 horsepower, just to put it in perspective.
Wow.
So you're like a commercial ROV is more like a modern car that has, you know, hundreds of horsepower, 250 horsepower to be, is like a common horsepower for a commercial vehicle. So it's very, it's not super responsive. It is super responsive it flies absolutely beautifully, but you're more controlling the velocity of it slowly. That's kind of, if
Right.
you fly models, it would be more like a helicopter versus a drone. The drone's almost instant, but a helicopter, you know, kind of, you have to wander around a little bit.
Yeah. How about these gauges on the screen? What do those mean?
So those are all of our pressure compensated housings, as we call them, are full of oil to keep them from collapsing. So you could picture if you blew up a balloon and put it in a pool, so that the air would stay inside and the balloon would stay inflated. Or if you're diving, for example, your variable ballast, you're putting air in to compensate. So on the ROV, we do that with food grade mineral oil. And Roger. And we have a positive pressure on them all the time. So there's basically a bladder with a spring that biases the bladder, and that maintains a positive pressure. So as we dive, any air gets compressed, and the temperature is getting colder, and we're getting more ambient pressure from the seawater. So we're watching those gauges to make sure they're always basically positive, and they're not rapidly changing. So we kind of know the numbers are all typically around 6 PSI.
Right.
Jaden's watching those. We log those as well to make sure there's a, you know, trend over time. If we had a slow leak, we would, you know, slowly bleed out. So we would try and recover the vehicle before that happens. So if you're ready, if you got any more questions, I was going to have you.
So that's all 7 pressure housings on the vehicle? Or are there pressure housings without compensators?
There are. So, for example, all the lights and the cameras are 1 atmosphere. And then the big bottle on Hercules with all the main electronics in it, all the power supplies, the computers, the fiber optic multiplexer, and you know, the controller for the manipulator. All those are 1 atmosphere, just like your, you know, regular electronics we have here in front of us. So they're in a titanium 1 atmosphere housing with penetrators for the electrical and fiber optic signals. All the oily ones are just in a, you know, you could actually take a tin can and hook a compensator to it, and it would go all the way to the bottom of the ocean, because it has that internal bias pressure, and so it's not going to collapse. And there are, there's the main electrical circuit, so that's all the J boxes on Hercules and Atalanta. There's some little gauges up there. And then we have the hydraulic power unit, so that has its own oil that's powering the electric motor is spinning a hydraulic pump, and that gives us, of course, the hydraulic power for the thrusters and the manipulator and the other wiggly bits like the sample boxes and porch and camera. The motor itself has its own compensator, so it's an electric motor and it has oil in it. And we have one that's isolated, the term, the lower left one there, that's for the high voltage J-box, so where the tether comes into Hercules, we keep that separated for what should be obvious reasons from the low voltage stuff. So in case there's an issue with that, it doesn't cross over to the low voltage. The thrusters have their own compensator. There's a bearing in the thrusters, so that's kind of a barrier between the seawater and the hydraulic circuit. Right. So as those are like old school crane seals, so any water that gets in past the propeller shaft doesn't wind up in our hydraulic power unit and contaminate the working system. So the pump and all the valves and stuff are sensitive to, you know, the oil has to be clean. Any particulate will clog up the valves and that'll cause us trouble. And then the manipulator has its own compensation system, so the electronics on the manipulator are separate from the vehicle. And I think that's about it.
Cool.
There's another one there that's 3,000, the top right one, that's the working pressure of the hydraulic system. So we monitor that to make sure we have the power.
Are we getting close to the bottom here?
We are. You're starting to get some beams clipping in there. So Jaden should be, when we're within 100 meters, Jaden should be in manual control. So they're going to remove the stick and go manual. And then for the ROV, I'll usually now click it out of autos. So I'll take control of it. So if you touch the stick on the button on the top or that one.
So just like that?
Yeah. So now you have control. So now all the thrusters are at 0.
Right.
So if you click in that auto heading button, which is this guy right here, that button right there. So now the vehicle's locked in on that heading until you twist it. And then we're going to want to thrust down with your left stick. So push that all the way forward.
All the way?
Yeah. So you see, that's a very nice touch, Harold. A lot of people sit down and just slam that thing. It's like, you know.
I'm scared to break it.
My 16-year-old, the first time we went driving, he just like floored the throttle and we went through the back door of the garage. So, yeah, you're now applying 100% down thrust. So Jaden needs to slow down a little bit, and you're gonna pass by. So you're actually above Atalanta at the moment.
Okay. So
you can see in those cameras you're gonna come by. So you now have 4 Doppler beams, and you have an altitude of 70 meters off the seabed. So we're going to come down to 10 to 20 meters, excuse me, below Atalanta. And if you want, you could give this one a wiggle just to see how it feels forward and backwards. It's not really going to go anywhere because it's at the end of the tether. And you can see yourself now in Atalanta's aft camera.
Oh, yeah.
So you're down below.
Huh. All right, so should I ease up a bit?
No, we're gonna bring the whole stuff down. Yeah.
Okay.
I'll stop you there about 20 meters off the seabed. So at some point we should start to see a hint of the terrain that the bathymetry that we're gonna take. And I think if I remember glancing at the screen, uphill's gonna be that way, so we should be good. In theory. So that's a good delta to maintain about 20 meters below Atalanta. So Hercules will hit the seabed before Atalanta does. So you're 30 meters off the seabed now, 20 meters below Atalanta. And you're slowly drifting back a little closer to Atlanta, which is actually what we want. So. And there's seabed in sight there in Hercules.
There it is.
So what I'll do
So-
now is I'll let go of the stick, and if the velocity will slowly come down, and Hercules, in theory, should stop sinking and start floating back up away from the seabed. So we have a bug, a known bug, that we call the double tap bug. So I'm just going to fix that for you. So now if you touch your auto depth button, it should actually engage auto altitude. And if the bug is not there, these won't go 100%. So you're now maintaining altitude, and you're maintaining heading, and Jaden should be all stumped on the winch, which they are.
Cool.
And we're ready to rock and roll.
All right. Thanks, Dan.
My pleasure. I'll get you up here next time. And if
Perfect.
you have a bash around the seabed.
First driver's ed lesson.
That was great.
Thank you.
All right. So we have reached the bottom. We are at 2,062 meters.
Do you want the big screen while you get your numbers there?
Yeah.
Or do you already have them?
Nope, I need to get them at the bottom now.
Oh my gosh, it's so much colder back here.
And uphill seems to be, am I facing the right way, Chris? Roger,
Yeah, the first move's going to be downhill.
roger. And it's going to be to the west. Yeah? Okay.
All right.
I'm gonna click in. Give us a minute here. We need probably about 5 minutes. We gotta do a system check here on the seabed. Get all of our ducks in a row. I'm gonna spin Atlanta around you while you're getting your numbers there.
Copy.
Well, what we're doing
Thrusters.
is
You
we're
want me to enable them?
yeah, that would help. Thank you. We are we're taking some baseline readings now that we're at depth, and we have to get Atlanta and Hercules settled out, and we're going to get the manipulator out and do a white balance for amber once we get a little closer to the seabed. And Chris has a navigational checklist that he's completing. It takes us about 5 minutes here to get set up. And we always change our ballast a little bit, so we've done some fine tuning, hopefully, and we're a little bit more positive than we were last night. So I'll kind of sneak down to the seabed here and let go of it and just see what happens. That'll tell me which way the current is pushing Hercules and what the ballast is like. Kind of getting a feel for it. It's like exploration, different every time. So I'm also kind of getting the lay of the land. This is a new neighborhood for me, so I don't know what's around here. And even though Chris says it's uphill over there, I never believe those navigators. And we're also going to test some of our functionality here. Make sure everything's working before we take off. You happy for me to be in auto XY, or you got to do your DBL thing?
No, we're good.
Roger. ROV is in auto XY. 4 meters off the seabed. I'm going to come down just a little bit for our white balance here. what that does is, Amber could probably explain what that does better than I could. Can you come down 5 meters for me, Jaden?
Yep.
Yeah, when we white balance, we are calibrating the camera to what a true white is and trying to make it kind of take out some of this blue cast that we're seeing overall.
You want the other lights on, do you?
Yes, thanks. Lasers off too, please.
Roger, lasers are off. Okay, somewhere in there should...
All right, going in. All right, going dark first.
Roger. Can you tap both the boxes closed while
Yeah.
both the sample boxes are still cracked open? Are we gonna want a seabed Niskin?
Affirmative.
Roger. I can get one while I have the manipulator out.
Is your end effector no longer floppy?
No longer floppy.
All right, happy.
Thank you.
Thank you.
Was that an affirmative, Brad?
Oh yeah, that was affirmative, sorry.
Taking a seat. We'll rack the camera back so I don't poke my eye out. I really want to try one of my tow rods. I didn't get the chance to yesterday.
I just took a beautiful Thermocam picture of the arm, so
Awesome.
I think we may be in business this time.
Yeah.
All right, Quinlan, we're gonna take our first sample here.
Noted.
Okay, Amber, call it.
Okay, you ready?
Alrighty.
All right, 3, 2, 1, Niskin. There it goes. All right.
Niskin, fire complete.
What sample number is that?
Sample number 15 in Niskin 1.
Okay, Science, I think if everyone else up here is in agreement, I think we're all yours.
All right, onwards and downwards to waypoint 2. Unless you want to look at jellyfish right there before we go.
Oh yeah, we gotta hurry up.
I'm seeing some immediate uphill to Atlantis port side.
Yeah, that's probably accurate.
All right, you can start moving the boat. I can look at jellyfish on the way.
Roger. Bridge nav 30250.
Just gonna dial in some sea ballast here. Try 35%. See if that slams me into the seabed. Where do you see this alleged jellyfish? Floating in the...
Oh, little
It's
one.
in the water column, small.
Roger. Hey, come down. Come down. Give me a little leash there.
Oh, wow.
Oh, wow. What type of jellyfish is that?
No idea.
Very active one.
Yeah.
The escaping kind. All right, thank you.
Escaping jellyfish. I lost the plot. Chris, what What?
250.
Roger, thank you.
So we're sitting on top of this large sediment mound that, you know, my amateur geology makes me look like this was a significant slump feature that's fallen down, probably actually slowly over time, not in one big cataclysmic slide. But if you look at the multi-beam, we're sitting on this giant rubble pile that's kind of clearly slid down the side of the seamount. So you got sediment at bottom, some moderate to mild bioturbation, so we don't see any of the bioturbators, but you can kind of see these different piles of sediment and the different color changes. That's from different animals rooting around in the sediment and turning it over, mixing it up, which is a really important ecological process in deep sea sediments. Got a shrimp.
Who would be the most expert or have the most expertise in geology on the ship right now?
May is our
Go-to?
geologist. Can we zoom sea cucumber quickly?
Sure. Go ahead, Amber.
This is a type of Holthurian. It's
Can you turn the
it's a
lasers off?
echinoderm.
Yep.
These are detritus feeders. They basically ingest sand and mud, the seafloor, and then slowly digest it through an actually super complicated mechanism in their guts.
This looks like maybe a synallactid.
All right, that's good, thanks.
Thank you.
Oh, I'm gonna rack my camera back out.
Oh boy, I see rocks.
Harold, why are rocks important?
Rocks are very important because a lot of the animals we're interested in, corals and sponges, crinoids, they require a hard substrate to settle on and grow.
60 meter step.
So where there's hard
250.
substrate, there are often corals, or at least most of them can't grow in the sand. So different habitats. Or if you're a geologist, you might like rocks for their own sake.
Nah, they're just substrate.
Your ROV pilot, you like them because they're not nearly as sticky as mud.
Big rock.
Oh, yeah. Yeah, it's a good target, sonar target.
Yeah.
I like it.
Are any of these rocks loose enough to pick up?
That's a good question.
Bridge
Could
down.
probably
full
pick
position.
up one.
Another sea cucumber here hanging out on a rock.
Angular rock. You like any of those rocks, Jaden?
I can't tell how big they are.
Ideally, we want to break one off, right?
Yeah, but
Yeah, I'm not seeing a lot of places to do that.
we're also literally in a slide area, so even these bigger boulders, I suspect, have fallen from above.
Yeah. Can we look at this C-pen?
Come up a bit. All right.
This looks like Umbellula sort of retracted into the sand,
Go ahead, Amber.
Maybe.
potentially.
Copy.
If it's Umbellula, it's a young one.
That's good, thanks. What's that mean? That was it.
Nope.
Fatal pilot error. So I changed my heading there instead of my using my laterals, and it causes the port vertical thruster, port horizontal to reverse
Yeah,
itself.
Let's look at that.
And
Please.
Yeah, can't tell if
that
that's a
tested it.
crinoid or what.
Do a quick zoom there, Amber.
Okay, copy.
We gotta make a move here. Happy?
Well, I don't know. If you got more, I'd like. I'm having trouble with this one.
I mean, that looks like a stock crinoid to me.
Yeah, I'm just not used to them being closed like that. But yeah, definitely crinoid. All right, thanks.
Interesting.
Come up a little bit more before we hawk all the tether there. Come up to 25.
Copy.
Right under you. We'd have to poke the rocks to see if any are loose. I can never tell by just looking. You can do that if you wish.
I do.
Roger.
Bridge nav, 15 meters, 070.
While you're looking for a spot to poke, could we have a look at this coral?
Sure. Go ahead, Amber.
Copy.
So it's a black coral.
All right, that should be good enough for 90. I suspect it's Bathypathes.
Roger. Can you give me just a bit more pressure on the starboard valve pack?
Are we trying to get a rock sample?
We're looking for a reasonable rock, yeah.
We're gonna.
Why would we want to get a rock sample?
The rock samples will help us date the feature and will help understand the plate tectonics of the area, as well as potentially understand some of the chemical composition in the crusts. There's a great debate about what makes a good rock.
Oh, yeah.
You want something big enough that it has a reasonable likelihood of having like original material in the center and not just crust, which on a feature of this age I don't think is too big of a risk. And in the best case scenario, you want it from when it's a semi-attached to the seafloor, light enough you can break it off, but attached enough that you don't think it's rolled down from somewhere else.
Oh, I
Zoom
see.
in there, Amber, for us, please.
but given that this is pretty clearly a giant landslide scar, or I don't think any of these could be totally called intact.
Okay, Jaden, get that
I bet
manipulator
these
out.
looked like
Poke some
possibly
of them rocks.
alternata based on the alternating branches.
That would make sense.
Just my guess.
Craft.
Little baby Chrysogorgia on there too.
Do you want more or less zoom here?
I think Brian wanted to see the coral while we're getting the manipulator out.
Oh, copy.
It's already got its little Europtychus crab in there.
This is a crab that we collected yesterday and could be a new record for the region.
Same genus. I think it's actually a different species though. The one that was on the black coral we collected was super purpley. This looks more like the kind of traditional.
I do a
But they were excited about it.
a real
in the
light
museum.
close jaw
They were.
poke on the rocks. Find one that moves and that they're happy with. Okay, Amber, you can go Wade. Dealer's choice.
That one's probably too big, yes?
Nope.
All right.
I don't want to have the coral on it too. Negative. Didn't move.
All right, second choice.
Could be. Yeah, that one's loose.
Can we look at the back side of it, pick it up and look at it?
Yep.
Sure.
Let me check the grip force this time.
Grip force should be set to 9, yeah.
Yep.
Grip force maximum. Rock crush.
Grip Force 9.
Power.
I think Grip Force 9 could be a good band name.
Totally a good band name.
The 8 to 12 watch has given themselves a name. We don't have a name.
What, Sponge Dungeon?
Sponge Dungeon.
Yeah.
So you want to, tilt that a little bit more.
The polyopagon.
You can push in a little bit there, Amber, and Jaden, if you do a slow spin there, I'm not sure what he wants to see there.
I think you wanted to see the underside.
Yeah, I just want to see if it was black all the way around or if there was a non-encrusted
Oh, look,
side.
you got
Oh,
two
two
for-
rocks.
2 for.
Yep, that works.
Okay.
In the basket, please.
Roger.
Thank you.
Starboard.
One of the ones that I haven't been doing, because I have the upper camera, but I'll put the PTZ on that one and you can see with the azimuth how it comes around. Okay, cameras. This one off, that one on. I'm going to make this easier for you. I'll go. If I can find the right button here. So I didn't realize how hard it is to see that little tiny box from over there.
All right, rock in the box.
Rock in the box. Nice job, Jaden.
Sample number 16 in starboard box E.
Excellent.
Starboard box closed.
Thanks, Hal.
I'm going to switch back over to the, so you can see your upper camera.
Right, while we're sitting right here, can we look at the zoom on coral right next to the porch?
Yeah, the one right there in front of it.
Yep.
Push the camera back out here.
Is that good for storing it?
Yep, perfect. Okay, Amber, I'll get a tight zoom on this. It's so close to you. You can go, probably go all the way there, I think.
This looks like another Umbellula sea pen.
I think it's Umbellula, not Coloblemnon.
Let me look.
All right, that's good. We're gonna look at the pictures later and argue about it.
Roger.
When you get the chance, the Orion arm is peeking out of the side on the
Roger.
river cam. Just a bit more.
Yeah. I gotta come up. It's hitting the rock there. It's still in there?
Yeah, I can still see the claw. That's good. Thank you.
All right, future Brian would like us to move the ship.
Roger.
All right.
You can get it going, Chris. By
You
the
ready?
time-
Okay.
Yeah, by the time it starts moving, I'll
Bridge nav, 40 meters,
tracks.
255.
unless President Brian finds some presents under here.
There is an anemone or something down there.
Yeah, there's
There's two.
a couple.
The one on the right in the sand is more interesting. The other one's a Venus flytrap. I think this might actually be a cup coral for you, Ben.
Or
Yep.
a Serianthid.
The one on the wall or the one down in
Uh,
the mud there?
Down. This one is the one
Right.
I'd like to get.
Go ahead, Amber.
What's this one called?
Not 100% sure yet.
This looks like a tube anemone to me. Serianthid.
Yep. Tend to agree with you. All right, that's good. Thanks.
Can go line, thanks. Jump for that rock, Hercules. He should be grot.
Scared the anemone.
Yeah.
I just want to welcome our viewers. We are on our second dive for Libu's Voyage 2. This is, no previous dives have been conducted on this unnamed seamount. This was mapped for the first time this morning.
Right, mapped right up until the last possible second.
Gotta make good use of every minute of ship time.
Yeah, they did.
So I'll just go ahead and introduce our watch while we're continuing to be looking. We have Brian on watch lead, Harold on science, Quinlan, data logger, Daniel on Hercules pilot, Jaden, Atlanta pilot, Chris on navigator, Amber on video, and myself, Kim, on science comm.
Our watch needs a nickname. I think it should have something to do with time travel.
Oh, yeah.
Time travel?
Yeah, you know, future Brian, present Brian.
Well, I guess that will be one of our goals by the end of our watch.
Could be squat lobster too.
Yeah, it could be. Or it could have something to do with epic fail.
Advantage of the
I
squat
don't know.
lobster.
Something Moby Dick related for Dan.
Oh,
Crawdad hunting.
Roger. Something about the one that got away.
It's one's plural now.
Push in there for us, Amber.
Ouch, gee.
This looks like one of these Homerion shrimp-like decapods.
Why is it a decapod? What does that mean?
So decapod means it has 10 legs, pretty sure. And that's a group that includes crabs and shrimp.
Looks very prehistoric.
I didn't even.
Yeah, that's a cool
10
looking one.
legs.
Thank you.
Yeah, we're going that way. We need to turn that way. That's looking rock slidey to me.
yeah, if I had to guess, we're going to see sediment, followed by talus slope, followed by sheer wall.
Oh, sheer wall. You're teasing now.
Is my prediction for this dive.
Little kid in me wants to see which of these rocks I roll down the hill so bad. This is about kids and throwing rocks in the water or rolling them down the hill.
Can we try and zoom on the branch point of this coral?
Absolutely. Come around this side. You can push in halfway there for me, Amber.
This is one of these bamboo almost whips, except it has one branch.
Okay, push in a bit more in there.
Looks like internodal branching.
Concur.
You can go a bit more if you want.
Yep,
Thank you.
definitely.
Bridge nav, another step.
Why is it? Why are you wagging your tail, Herc? Should have no command zone.
Yeah, 40250.
Quick look at sponge, please.
Sure. I'm gonna try the, well, never mind. I was gonna say I should try the downlights off, highlighting a lot of stuff in the water there. Go ahead, Amber. Definitely tell which way the current's blowing. Are you good, Brad? Or want more? Hi, Rachel. I don't mind at all. Thanks for that. Appreciate it. Would it help if I change the lighting at all, or?
I think she's off headset now.
Gotcha. I need to make some tracks. What am I doing way down here to the south? Bumping into rocks. I'm going to try without those down lights for a minute. Really need to adjust the lower mid lights down just a skosh.
You said the lower mid lights.
Yeah, you see the on the upper camera there, that kind of binocular look there. You can see just a hint of that shadow in the main camera, which is super annoying.
Ooh. What?
What is that?
What could this be?
Can you come up with your meters for me, Jade? Get a chance.
Copy.
Probably up 5 there, right under you now.
The odds are high we're going to want to sample this.
Right.
Bridge, hold position.
Hoping Les Watling is still in the chat, because this looks like some kind of Chrysogorgia.
Bridge nav, let's
Turn that.
do 15 meters, 070. Zero 70.
And I'm going to try and take some stills.
Yeah, I don't have that camera up yet, so I can't tell what's centered up and what's not. I should put it up here somewhere.
It's okay. Hey, Rachel, this is a good spot for you to mess with Triclops. We're going to be here a minute.
Gotcha, thanks for setting up Triclops now.
Make that a lower number. Yeah, we're going to want to probably take the top 10 centimeters of this.
Right.
Less things that might be a pseudo-Chrysogorgia.
On the main branch, or?
Doesn't matter. We just want
Come
probably,
down, come down, come down.
Okay.
we probably just want 4 or 5 branches on the main stalk.
Right.
So one of the things that's diagnostic sometimes on these corals is the branching pattern. So we're going to make sure we get a fair number of the branches so we can see what the angles are between the different branches.
It's like a pinkish color.
Yep.
Yeah.
Yeah, the polyps are in tissue are generally a little pink, and then the skeleton itself is is gold. It's actually a really pretty gold color. There's a whole bunch of different corals we loosely refer to as gold corals that are not at all, and they're for different reasons. So I honestly don't like using that term, but
pretty decent angle for a still. If you want to hang out for a second.
Yeah.
Dan,
Maybe
you have a tether
turn to
wrap,
the
you want
right
me to
just a bit.
rotate?
Nope, nope, no. Don't worry about that right now.
Okay.
You would probably pull me off. I'm just barely perched on a rock there, trying to get some images. Sorry about the dust in the background.
Okay, let's... can we get lasers off?
Roger.
Thank you.
You can just go for a zoom there, and we'll get the manipulator out.
That's so pretty.
yeah, this family of corals is one of my favorites.
Is that all the way, is it?
Yeah, a little more.
New wallpaper. One thing that's unique about the EV Nautilus is the acknowledgement of the space we are in. We're in the Palau water. Of the Palauan people. I just want to say thank you for allowing us to be in this space.
All right, I think we're good on the video front.
Yep.
Come down a couple more meters for me.
Copy.
Why are you drifting, guys? Why? It's very strange that it's not.
Yeah, so for this dive it is 16 hours.
Can you come a little bit wider on the image?
Yeah, having some
Yep.
strange stuff going on here with the...
All right, let me know when you're ready to pick where we're going to cut.
Go a little more western with the parking job here.
Can you go pull up like worms, or not worms, obus for Pseudochrysogorgia? Actually, look at obus. I want to see what the distribution is. No, Scott described this.
Yeah, so for the question about the booth behind us, yeah, this booth is for live interactions, Q&As you can schedule.
Can we
Class
push
where you
in a
connect
bit
with
there,
classrooms
Amber?
throughout the whole world.
Good.
Bridge nav, another 15-070.
All right, I think we want to cut right here.
Really?
What?
That's going to put Atalanta right on top of me, isn't it?
Not that really.
Yeah, well, it's over. It's in front of you. Do you not want that?
No, I'm good. Hold
Hold
that.
it.
Yeah, if you move,
Bridge nav, hold position.
if you move the ship around while I'm balanced on a rock here, it'll pull me off.
Gotcha.
Les, you really think this is a juvenile Metallogorgia? This is huge. I wouldn't call this juvenile anything.
FYI, folks, from the
How many
data there.
meters? Is it?
I mean, it's well over 1. It's hard to tell when it's bent
Oh,
over.
okay.
I'd say it's closer to 2 meters.
It's taller than me.
Okay, Brent, where did you? You have to point again. Sorry, I read it. You see there, grasshopper.
Yeah, so we are at 16 hours dive session. No, the team does not just sit here for 16 hours. We switch off every 4 hours. So this is the 4 to 8 watch you're watching right now.